Hello and welcome back to the next video in the series. Believe it or not, we're getting pretty close to getting all the bases down for programming, so you're officially almost a programmer now. So that's also pretty cool. So what we're going to talk about today is arrays. In order to bring up arrays, every programming paradigm exists because there was a problem with the ones there are limitations with what we've learned before, so new stuff came out that would help us come over those limitations, put those limitations behind. So let's talk about what problem we have in order to fix it with arrays. So when we worked on our self-checkout for Target in the previous sections, we had a function called checkout, and we gave it the price of 3 items, and it would calculate the sum, with the tax and the bag price, etc. But only limiting to 3 items at the time, we didn't talk about why. But why should it be limited to 3 items? What if someone wants to buy 5 items? Are we going to write another function and then have 5 items in the input variables? Right? Are we going to have price 1, price 2, price 3, price 4, price 5? But what if someone wants to buy 6? What if someone wants to buy 1? Then do we keep have to add functions here with different inputs? And that doesn't seem feasible, right? It's too much work. And as programmers, we are lazy, and some may say efficient. I don't want to insult anyone. But I consider myself lazy. I want to write as less code as possible to do as much as possible. So the programmers came up with a better way of doing this, and we call this arrays. So instead of having all the different items as different prices, what if there was a better way of doing it? So right now, the way we're thinking about it is price of item 1 is, for example, 15. Price of item 2, let's say, is 30. And price of item 3 equals 45, for example, right? So this is how we're thinking about it here. But what if we could change this into something like this? So what we really care about is we just need the list of the price of the items that we have. So instead of representing them separately like this, what if we could just say this equals to 15, 30, 45? What if we could represent it like this and just pass this thing to the function rather than all the different things separately? We just have them in a list and pass in that list to the function. And the list can have, separate sizes. It could be 1 item, it could be 10 items, it could be 20 items. It wouldn't matter to us. In the function, we're just going to say checkout. And then we're inside the input, rather than having all those separate variables, we're just going to give a list of items. So it's one variable, but inside of it, there's a list. And therefore, we don't have to define 50 different functions with different sizes of items that we could get. So before I actually show you how we do this, I do want to explain a different concept to you as well. So when you're actually going to the theater with your family, the first thing that you do is that you go online and you buy 5 tickets, for example. And the reason you do that, the reason you have to tell them how many tickets that you want to buy, is because the theater needs to reserve those spots, right? They have limited seating, so they have to reserve those spots for you. That's why beforehand you say, okay, I want 5 seats, and they will reserve it for you, and you'll get either a digital ticket or a ticket that you take in your hands, and that ticket represents that spot you have reserved in the theater. Right, so if the theater is like this, and this seat is A, this is B, C, D, and then E, when you get your 5 tickets, these get reserved, and therefore no one else can buy them. So that's the whole point of buying tickets for a theater, is because they have limited space, and they need to reserve them for people who want to come in. The same exact concept is true for variables in programming and what we've been doing until now. So whenever you say, for example, integer price, for example, what you're telling the computer is reserve one spot for me for the variable price. Just because the computer memory, which is something we're going to go into depth in the next videos, is that the memory in the computer also has limited space. So that's why it needs to know what it needs to reserve. So whenever you write a program and you tell it, integer price or float something, you're telling the computer reserve a spot for this variable, reserve a spot for that variable. But until now, we've been only doing it for one variable, so it's always been reserve one spot for me. But now that we're moving to arrays, we need more than one spot, right? So we need, depending on the size of the array that we're defining, we need more than one space. So let's cover how we do that. Let's cover the Java part of it. So the way we do it is, again, we have the type first. So let's, for example, for the prices, where we have a float. So that's the type of the items that we're going to have in the array. Now, to represent that it's an array, to tell the computer that it's an array, we do open bracket, close bracket in front of it. This tells the computer that we want to reserve space for multiple floats. So we give it a name. We can call it item prices. And again, we're going to choose a good name. And then what you need to do again is use the keyword new. You can think of new meaning that reserve, right? So if you like. And then you again put the type. You're saying reserve for me spaces for floats. And then you give it the size, like in the movie theater example where we said how many do you want. Over here we need to tell the computer how many spaces we want. So in our case, let's say we're going to say 5. So what this is basically telling the computer is reserve 5 spots for 5 floats. Under the name, item prices. So you can see it's almost exactly similar to you getting tickets in a movie. You're saying reserve 5 spots for 5 floats, right? Because the type is float. And then the name of our variable is item prices. So you can keep this in mind. So this is the type. This is, we're telling the computer this is an array. We give it a name. We need to reserve space. And again, this will be the type. And this is the amount of space we need. So now what we want to do, now that we have the array set up, how do we actually populate it? How do we, like for example, when you go to the movie again, so let's say, I don't want to write 5 full names here. So let's say as part of the family, we have, let's say we have people here, A, B, C, D, and E. Okay, so this is our family members. We have pretty simple names. And then when you go to the movie theater, let's say you've reserved 5 seats. And let's say each seat has a number assigned to it, right? So let's say 1, 2, 3, 4, and 5. So when you actually get to the theater, you want to tell all these 5 seats are reserved for you, but you want to assign them to the people in the family. So you say, okay, B, you can sit at 1. C, you can sit at 2. E, you can sit at 3. I'll sit at 4A. And then who's left? D can sit at 5. Okay, so that's how you do it in the theater. You tell who needs to sit where. Maybe there will be drama, so people need to be separated. I don't know. Think of the reasons. In a computer, the way that memory works is that the assignment is the starting seat. All right, let me do a proper line. So the starting seed always starts at 0 in a computer, and then it goes all the way up depending on the number, the length of the array that you've defined. So in our case, it's 5. So that's 1 space, 2 spaces, 3 spaces, 4 spaces, and 5 spaces. So if you do a array of size 5, the seats will be numbered from 0 all the way to 4 because you needed 5 spots, right? 1, 2, 3, 4, 5. Now you need a way to assign the numbers here. And the way you do that in Java is you put the name of the variable. So in our case, it's called item prices. And then in front of it, you open bracket or close bracket. And inside of it, you say what seat you want to assign to. So let's say in seat 1 or in location 1, I want to put the number 12.02. Okay, so what's going to happen is, what this means is put 12.02 at location 1. Okay, so now let's do another one. We want to put in location 3, we want to put 10. So what this is going to do is it's going to look for location 3 and it's going to put the number 10 here. So that's how you assign it. So you can put all the way from 0 to 4, but if you try to put an item in location 5, which doesn't exist, which we don't have access to, it'll give an error in the Java code. Okay, so it's pretty straightforward if you keep the example of the movie theater in your head, that this is the way you assign it. The semantics of the language, don't worry about it. It'll kind of sink in after you code it a few times. But as long as you understand it, the only thing that is a bit different than how we do things is just everything starts from 0 in a computer. So that's the only thing that may be confusing. Maybe to most people, it's natural that if we have 5 items, it should start from 1, 2, 3, 4, 5. But in a computer, everything just starts from 0. There's also one more way that you can create an array. So that's one way of doing it, the way I showed you, where you create the array first of a certain size and then you populate it like this. There's also a way where if your array is not that big and you want to kind of populate it at the same time that you create it, you can also do this. So you can say float. So the first part is the same. So you give it a name, I'll call it a list. And then you can do new. Again, this part is exactly the same. Now when you write float this time, you open parentheses, close parentheses, and you don't write anything in here, but you actually put the values that you want in this open bracer, close bracer. So you can write 1, 2, and 3, and then put a semicolon. And the reason you don't need to put how much space we need to reserve is because we're telling it how much space to reserve by actually giving it all 3 values. So when it sees that we have 1, 2, and 3, then what it's going to do is it's going to create an array of size 3, and it's going to do this automatically. It will say, it will do a list 0 equals 1, list 1 equals 2, and list 2 equals 3. So when you write this line here, it automatically does everything here for you. So when you're making like a array that doesn't have much elements inside of it, and you want to put the values from right there in the get-go, you can do something like this. I just wanted to show you. Or when you have bigger arrays of size 10, 100, 200, you can't, actually put every value there because that kind of defeats the purpose. So this is the way you actually do it. All right, so now that we have the array part down, let's talk about loops. And again, we're going to continue with our target example from before because we can build on top of it. So let's say a new shipment of shirts come into Target, a stock of 2,000 shirts, and the manager comes to us and says, okay, let's put these 2,000 shirts in our system and assign them a price of $55. So we sit down, we're like, okay, we know how to do the how to assign 2,000 spots for the shirts. So we go float shirts. We want an array. We'll call it shirts or shirt prices. And then we know we are going to do new float and size. There's 2,000 shirts, so we need 2,000 spots for the prices of each shirt. But now the manager has asked us to assign a price of 50 for each of them. Now we have a problem because we're sitting there, we're thinking, okay, how do we do that? If I sit down and start writing shirt prices, 0 equals 55, and then shirt prices 1 equals 55, and I have to do this one by one all the way to shirt prices $19.99. So by the time I get done with this, I'll probably have died of old age or boredom, whatever you want. This is not looking good. It doesn't fit in with our lazy programming mindset. And for that reason, to solve this problem, we came up with for loops, and by we I mean programmers, not me. So the way we do it is like this. So this is the format that we use. So we say for, I'm going to do it in blue here on the. Okay. All right, so we do for. I want to do exactly everything that you see here in 3 lines of code. So I say for integer index equals 0. So this is where we're starting at, index 0, just like we did here. And then we need to give it a condition until when it should keep looping. So I'm going to say while index is less than 2,000. So we're going up one by one until we reach 1999, then we want to stop. And each time we loop, we want to increase index by 1. And then we open bracer, and then we say shirt prices. And for over here, we have 0, 1, 1999. We're going to put the variable index. And then we're going to say equals 55. Put a semicolon and close bracer. So this 3 lines over here does everything over here. And this is what's amazing about programming. You write 3 lines of code which does the work of all of this. And this is why one of the reasons where when computers replace like some of the manual labor that we do, it's just so much faster and much more efficient. So over here, let's dive into what's happening. So again, over here is the starting. So this is the starting position. This is the condition to loop. And then this is the position change. So the first time that we go in here, I'm going to put a table here just so I can show you. So the first time we go in here, index is going to be 0, right? Because we just start here. We come here, we come inside the loop. Is 0 less than 2000? Yes. So therefore we go in here we say shirt price is 0, 0 equals 55. And then we do index plus plus. So index plus 1. So then we move over to second time. So we go back up here. We go back here in the for loop. Again, we check index, and now it's equal to 1. Right? Because at the end we did index plus 1 here. So now index is 1. Is 1 less than 2000? Yes. So again, we come here. We say shirt price is 1 equals 55. And then we do index plus 1. This index plus 1 is coming from here. Okay. So now I'll do one more. So we go into the third one. Now index is equal to 2. Is 2 less than 2000? Yes. Therefore, we're going to go inside the loop. And we're going to say shirt price is 2 equals 55. And then we do index plus 1. So we go all the way up to 2000. So the 2000th time that we go into the loop, I'm just going to put 3 dots so we can guess here. But now index is going to be equal to 2000. Now we're going to come here and we're going to say, is 2000 less than 2000? It's not, so we're going to come outside the loop. That's it, we're done. So we go all the way up to this, whenever this condition is not true anymore, we come outside of the for loop. All right, so this is the way loops work. You have your starting, where you want to start the loop from, the condition to keep looping, and how much the position changes every time you loop. So let me do one more example so you can see. So let's say we have a bunch of students and we want to print their names on the screen. Okay, so let's do that. So I'm going to create a shorter array this time. I'm going to say, since this is going to be the name of students, I'm going to use string. Okay, and then I'm going to put the two open bracket, close bracket, and I'm going to call it names. And I want to make it, I'll make it a shorter array this time. So new string, and I'll use the other method of creating a array. So I'm not going to put the size here. I'm just going to put the values. So let's do Jack, and then Jill, and Bob. Say we have 3 students. Now I want to print all their names, so I'm going to do a for loop. I'm going to say for, and then open parentheses, int. This time I'm going to, instead of writing index, I'm just going to write I. So int I 0, I'm going to start at 0. And while I is less than, so what's the size of our array? It's 3, right? So if you reserve 3 spots in the computer, we said it starts from 0, 1, and 2. So we want to loop until I goes from 0, 1 to 2, but it shouldn't go to 3. So while it's less than 3. So instead of manually writing 3, which is the size of the array, there's a function you can use. You can just say names dot length. This is the same as saying 3, right? Because the length of the array names is 3. So starting at 0, while I is less than the length of the names array, which is 3, and I want to, every time I go into the loop, I want to increment I by 1. So again, we open bracer. This time, all I want to do is print the name of the student. So I write system .out .print, and then here I put names, and for the address I put I, and then close it. So again, this one is going to start from 0, so it's going to come inside here. 0 is less than 3, and then it's going to print names 0. Right, so the first time it's going to do what this program is going to do, it's going to do print name 0. It's going to do that first. Then it's going to increment I by 1. So I will equal to 1. 1 is less than 3, so it's going to do print names 1. And then I is going to become 2. So it's going to see is 2 less than 3? Yes. So it's going to do print names 2. And then I is going to become 3. 3 is not less than 3, so it's going to exit the loop. Okay, so that's how for loops work. The more we write code with loops, the more familiar this is going to get to you. What's important right now is for you to understand the concept. So if you have any questions about the concept or if that doesn't make sense, make sure to put it in the comments. I'll be happy to answer. And now let's just try some of these in code as well. All right, so now let's try some of these things that we just discussed in our code. I'm working in the project that we were working in before. There was a good question about packages. Basically, packages are used for grouping up code together. It's really for organizational purposes. They don't actually affect the coding part so much. And the way you create packages is by right-clicking, going to new, and then over here you have package. And we'll talk about packages more when we get further and we need to create more classes. For now, we don't need to worry about it too much. So in this part, I'm going to code some things. You guys can watch me code, and then once I finish, try to do it yourself. You're going to struggle a little bit with loops at the start, but eventually it's going to get easier and easier to work with them, and they're very, very helpful. So watch me code first and then try to do it yourself. I'm just going to do some of the examples that we did on the whiteboard first, and then what we're going to do is go into our self-checkout and change our code for the function checkout to take an array instead of 3 items. All right, so the first thing I want to do is do that same example where we had the string of names and then we printed them on screen. So you don't need to write a new function here. You can just write your code in the main function. So you start with string, open bracket, close bracket, and we're going to call it names. And again, new string, and I'm going to use this method this time, and I'm going to give a bunch of names here. So again, Jack, John, and Grace. All right, so here's 4 names, and we're going to put a semicolon at the end. Now we just want to print these names on the screen. So instead of, and we're going to use a loop here. So we're going to do 4, integer I equals 0, I less than names.length, which would be 4 in this case because there's 4 items in our array. And then we're going to do I plus plus. So we're going to, I plus plus is the same as saying I plus 1. So instead of saying I equals I plus 1, so instead of saying this, the shorthand version of it is just saying I plus plus. And then we open bracer and close bracer. And over here, all we want to do is print out the name. So we do system.out.print, and we're going to say names I. That's all we're going to do. Now, if we run our code, we run our main function right here, we should see the name of all of everyone listed here. So the loop goes through it and puts all the names. What I want to show you is if you say, instead of 4 here, instead of the length of the whole thing, if I said less than 2, what do you think would be printed here? So in position 0, we have Jack. In position 1, we have John. You can think of the theater example. In seat 0, we have Jack. Seat 1, we have John. Seat 2, we have Jill. And seat 3, we have Grace. So what we're saying here is sit everyone, print everyone's name until seat 2. So this should print Jack's name, John's name, but not Jill and Grace, because Jill's in seed 2 and Grace is in seed 3. So let's run it, see if we're correct. And you can see it just printed out Jack and John's name. And the other thing that you need to keep in mind is if you try to go higher than the seats that you have reserved. So if I say print everyone's name from seat 0 all the way to seat 6, but only seat 0 to seat 4, seat 3 belong to us. 5 and 6 don't belong to us. So when I run this code, it'll give an error. And I just want to show you that. And this is the error that it's saying is index 4 is out of bounds for length 4. This is what this error means. It means we don't have access to the other location or index or seats, however you want to think about it. So keep this example in mind. And I want to show you the other example with the shirts as well. So we have an integer, or we said float. So we have float, and then it's an array. So I'm going to put the markers here. I'm going to put shirt prices. And I want to do a new int, and we have 2,000 new shirts. And then I want to, new float, made a mistake there. So I have 2,000 new shirts, and I want to make them all start at the base price of 55. So again, I do a for int I equals 0, and you don't have to have the name of this be I. You can say index, whatever name you like. While index is less than, again, we want it to do it for every shirt. So we say shirt price is the length, and then we do index plus plus. And then we do the same thing. We do shirt prices dot index equals 55. And that way we'll make everything be priced 55 for all the 2,000 shirts. So for example, if I print out the value of the shirts, let's say the shirt in location 1795, right? Some random number between 0 and 2000. So let's see the price of the shirt at location 1795. It should be 55. As you can see, the code is working, and we priced every shirt by 3 lines of code. Now the cool thing is, I just want to show you, if I make this 10,000 shirts, this is still going to work. It's going to make all 10,000 shirts $55 because we said while index is less than the length of whatever this array is, right? So even if we change the length of the array here, it's still going to be reflected in our loop. Now, if I check the price of, let's say, the shirt in position 9,255, it should still be 55. And we're doing that all in this few lines of code. I just want to showcase to you the power of programming and why it's so useful. So we did 10,000. I can change that to 100,000, and it's going to be just as fast. Okay. All right. Cool. So let me remove this. And what we're going to do now is try to update our self-checkout function to take an array of items rather than just 3, and then do the checkout for us. So let's do that. So instead of taking 3 items now, like this, we're going to tell the function that it takes an array of prices. Okay, so instead of having 3 different variables, we're just going to take one variable, which is an array. Now, when you're over here, we don't put equals new or whatever like that, because we're not actually creating a variable here. We're just telling the function that we're going to give it a variable of type float, which is an array. Okay, we're not telling it what array we're passing to it. We're just telling it, we're giving it a array of floats as one input, and we're giving it an integer as the second input. Okay. So now what we need to do for the sum of all items, before we used to do price of item 1 plus price of item 2 plus price of item 3. That's not going to be the case anymore. What we're going to do is we're going to create the sum of all items like before, and we're going to make it 0. Now what we need to do is create a loop, go through every price and add it to our sum. So we know how to do that now. We're going to write a for loop here. And we're going to say for int index equals 0, index less than the price's length. So however many prices that we have, the index needs to be smaller than that. And then we're going to do index plus plus. And let's open bracer, close bracer. And what we're going to do is we're going to say sum of all items equals sum of all items plus the prices, the price at index, whatever index we are. Right? So every time it's going to go through each price that of the items that we bought and add it to the sum. A shorter way of writing this is the following. You can just say sum of all items plus equals. So this line here, line 20 and line 19 are exactly the same. Line 20 is shorter and easier to write and maybe easier to understand, so we're going to remove it. Okay, so for every price, we're just going to add it to the sum. And then the rest of our code remains the same because we calculate the bags and then we calculate the tax and then we just add all three together. Now to make sure our code is working, and I did this on purpose because I want to show you guys the power of tests. So if you recall, last time we wrote the self-checkout test and we wrote when buying 3 products, total sum is the sum of the tax and the bags. So now, even though we've changed the code to take the list, this test should still pass. And instead of giving it the prices of 3 different items, we can give it a list. So if I give it a list of 3 items with the same exact price, so we had, let's see, what did we have? 50, 10, 30. Right, so if I make this an array and say 15, 10, 30, let's make an array here and we'll call it float prices equals new float. I think you guys should know this by heart now. And then we're going to give it 50, 10, 30. So the same prices that we had before. Right, now I'm going to erase this, and instead of all of this, I'm just going to write prices. Okay, so I'm giving the same prices as we had before. Now I'm giving it as an array, but the result should be exactly the same. So if we've written our code correctly, this test should still pass like it used to pass before. And voila, we have it working. Now the cool thing is, now you're not limited to buying 3 items. You can buy as many items as you want. And the self-checkout will work just like in Target. So let's do an example here for you. So let's go. I'm going to go into the main function and showcase the power of this loops and everything. So let's say we buy a lot of different items, 80, $2, 250, 2.5F. I don't know, $18, 220.5. Let's say we buy a TV, 1200, right? So how many items do we have here? 3, 4, 5, 6, 7, 8, 9, right? So we bought 9 items. All we need to do is let's just print the result, and we're going to call the, oh, I forgot to create the checkout. So let me copy the self-checkout code here. All right, so let's create our self-checkout, give it a tax percentage and a bag price. This is the 10 items that we want to buy. All we need to do is call that same function that we wrote, give it the prices and the number of bags, let's say 5, and this code is going to work just fine. It's going to calculate the sum of all of this, add the tax, and we owe Target 1876.6. And you can keep playing around with it, and this is the beauty of it. You can keep adding more items and more items and more items. It won't matter. The code will be able to handle it. 274.6. And this is the beauty of programming. So give it a go. See if you can pull it off. And enjoy the process. I hope you enjoyed the video. Again, if you have questions as things are getting more complex, please let me know. And I'll catch you in the next one.